This conference will now be recorded.
Hello everyone. We'll start with the model which is known as Bohr's model for hydrogen atom, and after that there will be some problems related to this model because numericals and problems related to this model, that is very common. And after finishing that, if time permits, we'll also discuss dual nature of matter and De-Broglie's principle. Fine. So Bohr's model for hydrogen atom, we have seen the work of Planck and Einstein, and this showed that the energy of electromagnetic radiation that is actually quantized in nature. That means h nu, which is known as a single packet of energy, so that will be available. It is not continuous in nature, it is quantized in nature. Now, extending this Planck's quantum hypothesis to the energies of atoms, that is based on this concept, which we have already seen. Now, based on this concept, Niels Bohr, he makes some hypotheses for the energies of atoms, energy levels of atoms. And he proposed this new atomic model, which is mainly for hydrogen atom. And here we will see what are the assumptions that are present in this Bohr's model. Okay, 3 to 4 assumptions are there. So as it is already mentioned that extending Planck's quantum hypothesis, that means here energies of the electrons that will be quantized in nature. So that is the first assumption, as you can see. Then electrons, they are revolving around the nucleus in a certain fixed circular path. So if it is nucleus, there will be some fixed path. Okay, like this. So this is one orbit. Then there is another orbit. So these are stationary circular path, or known as orbit. Okay. Electron can revolve only in those orbits in which angular momentum, MVR, product of mass, velocity and radius. When we say normal momentum, it is actually mass into velocity, but when it is angular momentum, it is mass into velocity into radius. So electron can revolve only in those orbits where this angular momentum of the electron, it must be equal to integral multiple of h by 2 pi value. So h by 2 pi is Planck's constant divided by 2 into pi. Pi means 3.14. So this total quantity is basically a constant. But remember, this condition must be fulfilled. That is, the angular momentum of the electron, it must be fulfilling this criteria, which is MVR equal to n into h by 2 pi, where n is equal to 1, 2, 3. So n value, it can be only integers, not any fraction value. Fine. So only when these conditions are fulfilled, that is angular momentum, it is, see here also that some quantized nature is present. It will be either h by 2 pi, or it will be 2h by 2 pi, which is nothing but h pi, or it will be 3h by 2 pi, or it will be 4h by 2 pi. So only these fixed values are present, which is also a type of quantization. Now, as long as electron revolved in this fixed stationary orbit, there is no loss of energy. As long as they are simply revolving, there is no other process going on. So as long as this is happening, there is no loss of energy. But there will be absorption of energy or emission of energy, that we'll see in the next 2 points. So when energy is supplied to electron, suppose we are supplying energy to electron. So under that condition, what will happen? It will absorb this energy, and after absorption of energy, now the electron can jump from lower energy level to higher energy level. So here the lower energy level we are considering E1, and the higher energy level we are considering E2. So suppose if it is nucleus, there are some fixed orbit. So this is energy level, suppose it is 3. Suppose it is 3. Next one is 2. This is 1. So when electron, it is moving from 1 to 2. That means obviously some extra energy we are supplying to the electron. That is why it can absorb the energy and it can jump from 1 to 2. Similarly, it can jump from 1 to 3 depending on how much energy we have supplied. So when we are supplying energy, there will be some transition from lower energy state to higher energy state, and the opposite process, that is, suppose we are not supplying energy, but now the electron is jumping from higher energy state to a lower energy state. So now the electron that is present in some higher energy state, so suppose the electron is present here. So electron is present here. So from 3 orbit, now it is coming to orbit number 1. So that means now there will be transition from higher energy state to lower energy state. Here it is mentioned E2 to E1. It may be any other state also. But important point is now excess energy will be emitted in the form of radiation. That is the difference with the previous process. Okay. So the first process, that is absorption energy, when we are supplying excess energy. And the second process is radiation, when electron is jumping from higher energy state to lower energy state. The frequency of radiation absorbed or emitted when transition occurs between two stationary states or two stationary orbits that differ in energy by this amount daily. So here, as we have considered transition from E2 to E1 or vice versa, but important point is what is the energy difference between these two orbits, that is del E. So del E is basically E2 minus E1, because E2 will have higher energy. So if you take this difference, it will be positive value. Now we know that E is equal to h nu. That means when it is daily, that must be equal to h nu. So daily is equal to h nu. So if daily is equal to h nu and this is nu, that is frequency, it must be daily divided by h. So the corresponding frequency, how you can get? You can get from this formula E2 minus E1 divided by h, because this difference in energy, that is actually equal to h nu. Okay. So here only, that is successive energy levels we have considered. It is not E3 or E1, because if you consider E3 minus E1, then there will be some multiplication of the value of h nu. So here we have simply taken the next energy level, that is 1, and the next one is 2. So that is why the difference is equal to h nu, and nu will be equal to daily divided by h. Now we will see some formulas. Derivation is not required, but simply you have to remember these formulas, which are basically based on Bohr's model for hydrogen atom, and these formulas are important when we will solve numericals on problems. You will require these formulas again and again. Okay. And also in these formulas, we will try to see, for example, suppose it is radius Rn. N may be R1, depending on which orbit you are considering. It may be R2, R3, R4, like this. So Rn is equal to, there is some constant 0.529. Sometimes it is also written as simply 0.53. Or simply 0.529 into n square. N means it may be that is which energy level we are considering, that is 1, 2, 3. So that will be mentioned in the problem. And Z is atomic number. So for hydrogen atom, it is 1. But suppose if there is any other atom, such as if it is lithium, it will be Z equal to 3. If it is helium, Z will be equal to 2, like this. So Z is atomic number, and n square, that is the energy level, and here A, that is actually A naught, which is the unit, angstrom. It may mostly it is expressed in angstrom, so that is why it is shown here. Okay. Now one important thing from this you can understand, that Rn is proportional to n square directly, and it is inversely proportional to Z. So together we can write n square divided by Z. So Rn is proportional to n square divided by Z. And it has to be, because see, when energy level is increasing, that is from the nucleus, the distance of electron is increasing. That means radius will also increase. So it is expected that Rn will be proportional to n square. It cannot be inversely proportional, because energy level increase means also increasing radius. Fine. The next formula is energy formula. En, that is the corresponding energy in level n, that is equal to minus 13.6 and z square divided by n square. Now here the unit for energy that we are using is electron volt. And remember, this amount of energy, that is actually per atom. So why it is important to understand? If in the problem it is asking per mole, then obviously you have to use this formula, and then with it you also have to multiply Avogadro number. Because when it is asking per mole, you have to consider Avogadro number of atoms. So that is why, if this is the energy for one single atom, now for Avogadro number of atoms, obviously you have to multiply it with 6.023 into 10 to the power 23, which is Avogadro number. Okay, so be very careful when you are reading the problem, whether it is mentioned per atom or per mole, that you have to be careful. So it is electron volt unit. There is a negative sign, and here we can say that energy is equal, that is proportional to En, that is proportional to z square divided by n square. That means when n value is increasing, that is the orbit that will increase. Now energy, it is inversely related. Fine. And if you consider this atomic number z, that is directly related. So this proportionality relationship, if you can remember it, it will help you to solve the problems. Okay. And if you want to convert this energy unit to joule, for that, here it is mentioned already that 1 electron volt, that is equal to 1.602 into 10 to the power minus 19 joule. So in the question, if the final answer, if it is asked in joule unit, then whatever value you are getting in electron volt unit, that finally you have to convert to joule unit. Okay. Next, if we convert it to joule unit, the third formula that you are seeing here, if you multiply this 1.602 into 10 to the power minus 19 joule with the value 13.6, then you will get this one, 2.18 10 to the power minus 80. Rest of the part, there is no change. It is still z square divided by n square. But now the energy, that is actually in joule. And again, it is obviously per atom, not per mole. Okay. Then the next formula, that is for velocity. So velocity is equal to, remember, 2.18 10 to the power 6. And here one important point, velocity is proportional to, just from the formula you can understand, velocity if you remove this constant, then velocity is proportional to z by n. Okay, so when n value is increasing, velocity will decrease. When z is increasing, velocity will increase. Okay, remember this. And here unit is meter per second. So when you are using this formula, remember 2.18 into 10 to the power 6, it is actually in SI unit. Meter per second, you can obviously convert it to some other unit. Okay. Now some more information regarding velocity and frequency that you can see here. Time taken for a particular electron in Bohr orbit, this is time t, capital T, that is actually equal to 2 pi r divided by v, where v is velocity. Now what is 2 pi r? 2 pi r basically in circular path, it is the value of circumference, the formula that we use for any circular, that is any circle. if it is a, what is the circumference formula, it is actually 2 pi r. So circumference, if you divide it by velocity, you will get the time taken, that is for a particular electron in Bohr's orbit, because it is the total distance that it has to cover. So this is the circumference, this value is 2 pi r, and if this distance is divided by velocity, because 2 pi r, that is in distance unit, and velocity, it is distance per second. So distance cancel, ultimately the unit in the right hand side, that will be in second, that is time unit. So this is the time which is required for the electron in a Bohr orbit, and that is given by t equal to 2 pi r by b. Now we know that frequency, which is expressed as nu, this is actually per second unit, right? Or we also use hertz unit. Now when I'm saying per second unit, that means it must be equal to 1 by t. So t is equal to 2 pi r by b, that means 1 by t, which is nothing but frequency. This 1 by t, that will be equal to just inverse of 2 pi r by b, that means v by 2 pi r. Okay, so this relationship, it will help you to solve problem when it is asking frequency related. Okay, and also if 1 by t is equal to v by 2 pi r, you can also find that v is equal to 2 pi r by t. So different types of relations you can see here. It depends which informations are given. If time is given and r value is given, then you can find velocity, or if v and t given, you can find r. Okay, so remember this formula. Now here electrostatic force, that is equal to centrifugal force. So when the electron, it is revolving in the orbit, just remember the Bohr's model for hydrogen atom, two different types of, that is two opposite force which are complementary to each other, that is actually working on the electron. So centrifugal force and electrostatic force. Electrostatic force is force between two opposite charge. So we know that electron is negatively charged and nucleus, it is positively charged. So between these two types of opposite charge, there will be some electrostatic force. So electron will be attracted towards nucleus. And so because of this electrostatic force, there is some inward pull the electron will feel. This is the inward pull, that is attraction towards nucleus, and that is because of this electrostatic force. Another force is there, which is applicable for any, that is, if you are, there is, just consider any moving object that is moving in surround circular path. This centrifugal force, that will always be applicable. Now this force, its direction is towards outside. So electrostatic force, it is towards electron, that is inward pull, and centrifugal force, that is actually outward pull. And these two when balanced, so that is why here it is written equal to sign. Electrostatic force is equal to centrifugal force. So these two when it balanced, then only the electron, it will can remain stable. Because if you only consider electrostatic force, what will happen? The electron will jump to nucleus, but that actually doesn't happen. If you only consider centrifugal force, what will happen? The electron will be, that is, it will shift from this orbit to infinity. That is also we do not observe. So there is some balance between these two opposing force, and that is why electron can maintain its position in the orbit. Okay. Now electrostatic force, that is expressed in this way, which is Z is square divided by R square, and centrifugal force, that is R mv square divided by R. Z is atomic, that is actually the charge. So for hydrogen atom, it will be 1, and R is radius, m and v mass and velocity. If you cancel this R in the denominator, now you can write Z square by R, that is equal to mv square. Okay, so we can reach this relationship. Now we will apply this relationship to find out kinetic energy, potential energy, and total energy. So see, kinetic energy, we know it is expressed as half mv square, and potential energy, that is equal to minus z square by r. If you are thinking that why we are not doing derivation, because that is beyond syllabus and that is not required, so you just have to remember the formulas. Fine. Potential energy, that is negative sign, then z square by r, but we have already seen here that z square by r, that is equal to mv square. So that is why now we can write in place of z square by r, we can write mv square. And total energy is kinetic energy plus potential energy. So what you will do, you will add these two. So kinetic energy we have already see, it is half mv square. So put the value of kinetic energy, then there is a plus sign, and then it is potential energy. So half mv square, basically you can also write it like this, as it is plus, then there is negative. But whatever you will do, ultimately you will see that total energy is equal to minus half mv square. So another way we can say that total energy, that is equal to minus of kinetic energy, because kinetic energy is positive half mv square, right? So total energy, if it is minus half mv square, so as if it is minus kinetic energy. Okay, so this is another way of saying this, because why I am giving significance on this fact. If you are getting some true false or choose correct statement type of problem, maybe one statement will be given as kinetic energy, it is total energy, that is same value of kinetic energy, only difference is there is a negative sign. So numerical value is same. So this type of information, just keep it in mind, because to solve problem or to choose the correct statement or to choose the incorrect statement, we will need all these informations, right? So here we'll solve this problem. According to Bohr's atomic theory, the first statement, A, B, C, D, total 4 statements are there, and you have to choose the most appropriate answer from the options given below. So in first option, it is only statement C. Then the second option, it is only statement A. Then the third option, total 3 statements correct. And last option, total 2 statements out of 4 correct. Okay. So the first statement is saying that kinetic energy of electron, it is proportional to z square by n square. Now we have seen that kinetic energy, what we have seen? Just we have seen that is minus half mv square, right? So in kinetic energy, velocity term is involved. Half mv square. But just remember in the previous slide, what we have seen, that v is proportional to z by n, right? That means v square, that should be proportional to z square by n square. So we can write that kinetic energy, which is proportional to v square, it must be proportional to z square divided by n square, because v is proportional to z by n. That is why we can say so. So this statement is basically correct, true. Second statement, the product of velocity of electron and principal quantum number, that means v into n, that is proportional to z square. Now we have seen that v is proportional to z by n, that we have already seen, right? So if v into n, that should be v into n, that should be proportional to z divided by n into n. That means V into n, this product is directly proportional to Z. It is not that it is proportional to Z square. So this statement is not correct. That is, second statement is not correct. Okay, come to the third one. Frequency of revolution of electron in an orbit Z cube divided by n3. Remember again in the previous slide what we have seen. Frequency 1 by t, that is equal to V by 2 pi r. So now we will apply this. So suppose frequency is, mostly we express it in nu, but here I am writing it in terms of f, that is equal to 1 by t, and 1 by t is equal to V by 2 pi r. And in place of V, we can write it as it is proportional to Z by n. V is proportional to Z by n, that is already mentioned here, and 2 pi r, that is still present. That means finally what we are getting, Z by n, V is proportional to Z by n, so I can write V is equal to some constant V by n, because we have to find proportionality, because I can place easily any constant. So in place of V, now I can write K into V divided by n, okay, multiplied by 1 by 2 pi r, okay. And remember, r is proportional to what? Because ultimately you have to reduce it to Z and n. So again, go to the previous slide. We have seen that r is proportional to n square divided by Z. We will use it now. So if r is proportional to n square by Z, so what we can write here, it is 1 by r. That means it will be n square by Z. So now it will be Z by n square. Okay. So if, okay, let me do it freshly. One by t, which is basically frequency, that is equal to V by 2 pi r. So we can write that frequency, that is proportional to V divided by r. Now V is, we know it is Z by n. Okay. So multiplied by 1 by r, and 1 by r is proportional to n square by Z, so it should be proportional to Z by n square. So now I am writing Z by n square. So ultimately what you are getting, it is Z square divided by n cube, but here it is mentioned Z cube by n cube, but it is actually Z square by n cube. So this statement is also not correct. B is false, C is also false, A is correct. Now here B and C false and A is correct, but we also have to check the next one, which is Coulombic force of attraction. Now what is Coulombic force of attraction? Remember in the last slide again, we have seen that electrostatic force is this one, and electrostatic force is attraction between positive charge and negative charge, which is another way of saying Coulombic force. So we can write that Coulombic force, that is actually equal to Z E square divided by r square. Now r is proportional to n square by Z, right? That means Coulombic force, which is equal to Z E square by r square. So we can say Coulombic force is proportional to Z by r square. Now r is proportional to n square by Z. So we can write Z multiplied by 1 by r square, which is another way of saying Z square divided by n4. So see, z into z square by n4. That means Coulombic force is proportional to z cube divided by n to the power 4. So this last statement is correct. So considering all these facts, option 4 should be the correct option. Fine. Next problem. Given below two statements. Statement number 1, statement number 2. According to Bohr's model of an atom, qualitatively, the magnitude of velocity of electron increases with decrease in positive charge on the nucleus, as there is no strong hold on the electron by the nucleus. So it is saying that velocity of electron, it will increase with decrease in positive charge. So if this statement is true, according to this statement, velocity that should be inversely proportional to z. This must be true. But what we have seen, remember in the previous, that is the first, second slide of today's, what we have seen, V is proportional to Z by N, right? So if V is proportional to Z by N, this cannot be correct. If this is not correct, this statement is also not correct. So this is false. Come to the second statement. According to Bohr's model of an atom, qualitatively the magnitude of velocity of electron. Again, we are talking about magnitude of velocity of electron. In the previous statement also same thing. But in previous statement, it is saying something about the relationship between velocity and z. And in the second statement, it is talking about velocity of electron. It is increasing, decrease in principal quantum number. So principal quantum number is this one. And here from this relationship, you can understand that V is inversely proportional to principal quantum number. So when there is increase in velocity, there should be decrease in principal quantum number. So this second statement is basically correct. So to solve this problem, you just have to remember this relationship. How V is related to Z, is it proportional or inversely proportional? How V is related to principal quantum number, is it proportional or inversely proportional? Okay. So here first statement is not correct, but second statement is correct. Here it is simply mentioned that velocity of electron in Bohr's atom, V is proportional to Z divided by N, but Z is atomic number of atom. It represents the positive charge, because here it is not directly mentioned atomic number of atom in statement 1. If you just read it once more, it is saying increase with decrease in positive charge, but positive charge is nothing but Z in this case. So this relationship, if you can remember, you can easily answer this question. So Z increase, velocity increases, and when N decreases, then only velocity increases. First statement false, second statement correct. So we are trying to solve as many problems as possible based on Bohr's model, because these questions are really important, and that is there. You will see this type of questions are coming in exam again and again. Right? The difference between the radii of third and fourth orbit. That means n is equal to 3, third, n is equal to 4, fourth. For lithium 2+. Now it is not hydrogen atom. But see, lithium atomic number is 3, but it is having oxidation state 2+. That means it is also one electron system. One electron system like hydrogen. So you can apply Bohr's model, which is applicable for a hydrogen like system only. And this difference is del R1. You have to find the difference between the radii of third and fourth orbit. Again third and fourth, but now the system is different. It is helium plus. Helium, when it is neutral, atomic number 2. That means total 2 electrons are present. But when it is carrying single positive charge, that means now only 1 electron is present. 1 electron is lost. So this is also 1 electron system, right? So hydrogen Bohr's model applicable. Here the difference is del R2. You have to find the ratio of these two difference. Options are there. Okay. We have seen that R is equal to 0.529 multiplied by n square by Z, right? Now, if it is true, then for lithium 2 plus system, this del R1, that should be equal to R4 minus R3. Okay, that means here n value is 4 for R4, it is 3 for R3, but Z is common. Here Z is 3. So we can take common 0.529 divided by 3, and inside for R4 it is 1 by, sorry, it is not 1 by, it is simply 16 minus 9. Okay, so you will get something like this, and 16 minus 9, it is 7. Similarly, del R2, that will be equal to 0.529 divided by 3. Sorry, now it is not 3 because it is helium 2 plus system. Now it will be 2. Okay, and inside again it is 16 minus 9. So see, even you don't have to complete the full calculation. Without doing that also you can solve this question. Now you can see R del R1 and the value of del R2 both. So when you will take this ratio del R1 divided by del R2, this part will be cancelled because it is common for both of them. But del R1, 3 in the denominator. So ultimately this ratio, that is del R1 divided by del R2, it will be 2 by 3. Okay, so suppose it is equation number 1, it is equation number 2. Just divide equation number 1 with 2. Okay, so this should be the correct option. So here the formula is given, that is formula for Rn. The same formula you have also seen 2 to 3 slides before. Just put N and Z. Z is 3 for lithium, 2 for helium. Rest of the part there is no change because in both cases this is the difference between third and fourth. So it will always be 4 square minus 3 square. So N is equal to 4 for fourth orbit. It is equal to 3 for third orbit. Okay. If the radius of third orbit of hydrogen atom R, then the radius of fourth orbit of helium plus system. Helium plus, we know it is also one electron system, and we have to find the radius of fourth orbit of helium plus. And another information is given that third orbit of hydrogen atom, that is R. So again we will use this formula, that is Rn is equal to 0.529 n square by Z. So as it is, that is according to this information, we can write R should be equal to 0.529 n square by Z, and n in this case is 3. So it is 3 square divided by 1. Okay. So it is 0.529 multiplied by 9. So just keep it like this. You don't have to do the full calculation. Don't waste your time. Now come to the helium system. So when it is helium system, that is helium plus, now again the same formula we will use 0.529 multiplied by, now it is fourth orbit, so it should be 4 square. N value is 4 now, and divided by 2, because for helium Z is equal to 2. Okay, so suppose this is equation number 1, this is equation number 2. So what we will do, we will take the ratio. So if you take the ratio of R He plus and R basically I want to write simply R because it is already given in the question, it is R. Okay, so what we are doing, we are basically doing equation 2 divided by 1. So here which parts will be cancelled? 0.529, this part will be cancelled, and it is 4 square, which is 16. So 16 by 2 divided by 3 square, that is 9. So after simplifying, you will see it will be 8 by 9. So now we can write that RAG plus, that is equal to 8R by 9. So which option should be correct? R into 8 by 9. So option 3, that should be correct option. Okay. Now from Bohr's model, whatever we have seen, we will try to apply these postulates or assumptions to hydrogen-like system. We know that line spectrum we have seen in previous classes for hydrogen. So this is the observation. Now we will try to explain this line spectrum of hydrogen that we have already seen by applying the postulates of Bohr's. Applying the postulates of Bohr to hydrogen-like system. To hydrogen-like system, which is basically one electron species. There may be any other type of atom also. You can take helium plus. Remember the problem we have just solved. Here we have used these two species. These two are also hydrogen-like species because they have lost one electron for helium and for lithium 2 electrons. So that is why it is also hydrogen-like system. Applying Bohr postulates to hydrogen-like system, the radius of nth orbit and the energy of the electron that is revolving in nth orbit, that we have already seen. Remember the formulas? So it is just saying about that. Now there is a negative sign in the energy, right? So this negative sign, it basically the significance is, it means that energy of electron in an atom is less than the energy of a free electron. So free electron means which is not revolving nucleus. Suppose it is somewhere in infinity. So compared to that, here energy of electron when it is present in the atom, it is revolving surrounding the nucleus. Obviously now the energy is less, so that is why there is a negative sign. Now a free electron at rest is infinitely away from the nucleus. So that is why now as if it will have energy level 0 because it is infinity. Sometimes it can also be written as n infinity. Okay. Now two processes are possible. One is absorption, another one is emission. So when it is absorption, we know that the electron is moving from low energy level to high energy level. That means n final. Nf means n final. So suppose it is moving from 1 to 2. So n final, it must be greater than n1. So for absorption process, this condition must be fulfilled. Nf is greater than n1. Now when Nf is greater than Ni, Ni means I means initial, F means final. Now from this relationship, remember this type of relationship we have already seen. That is how energy is related. And in this case, okay, I will want to show this previous relationship that we have seen. So here what we have seen, remember, just focus on this part. En is equal to minus 13.6 in EV, but in Joule it is minus 2.18 10 to the power minus 18. Now for hydrogen like system, suppose it is for hydrogen, then Z is, that is the simplest one I am considering, Z is 1. So in this case, En is equal to minus 2.18 10 to the power minus 18 into 1 by n square. So suppose En, it is absorption process, it is going from low energy level to high. So 1 to 2. That means first it is E1. In that case, it is initial state Ni, which is 1. And when it is final, EF, that is n equal to 2. So when you will take the difference E2 minus E1, or any other energy level. For simplicity, I am considering jump from 1 to 2. So in that case, you will take this part common. Inside the bracket, it will be 1 by, that is final value and initial value. So that is actually we are seeing here. Okay. So here initial will come first because we are avoiding this negative sign. If you are putting a negative sign here, you will see 1 by nf square will be coming first and then minus 1 by ni square. So be very careful which one you are writing first. Depending on that, there will be negative sign before 1.2.1 is this value, or there will not be any negative sign. So when we are writing in this way, that is first you are writing 1 by ni square, then minus 1 by nf square. Then for absorption process, as in final state it is having higher value than in initial, so daily will be positive. Now why it is positive? Because when nf is high, that means here denominator compared to this denominator, obviously it is high. Now denominator high means this total value that will be very less compared to this one. I am trying to say that now 1 by, if nf is greater than ni, then ni square that will be greater than 1 by nf square when nf is greater than ni. So that is why the overall value that you are getting, it will be positive. But when it is emission, that is you are considering that electron is moving from high energy state to low energy state. So under this condition, initial state is high. Suppose it is moving from energy level E2 to energy level E1. So now this is final state. This is initial state. So now initial, that is Ni is greater than Nf. Okay. So if it is so, now 1 by Ni square, that will be lesser than 1 by Nf square. That is just the reverse process, the other possibility. And energy will be negative. So now this value, it will be lesser than 1 by Nf square. So that is why this total quantity will be negative and you will get a negative sign before this. Okay. So if I write instead of del E, you can also write h nu in the left hand side. Rest of the part there is no change. If it is so, now nu will be equal to, just divide this total term by h, Planck's constant. Then you will get something like this. Fine. Another relationship also important, which is in terms of wave number. So when it is wave number, that is nu bar, which is nothing but frequency divided by velocity of light. Now if frequency is 3.29 10 to the power 15, and if you divide it by the value of velocity of light, you will get, that is, see, it must be in meter per second unit. Be very careful about the unit. This total term of energy, that is actually in joule. So when you will use C value, it must be meter per second. And ultimately, the unit of nu bar will be, after dividing this by velocity of light, you will get the wave number, which is 1.09677 into 10 to the power 7, rest of the part as it is. Remember, the unit is meter inverse because nu bar is nothing but 1 by lambda, and lambda unit is wavelength, distance unit. So nu bar must be distance inverse. So that is why it is meter inverse. Now, if you can remember, when we have discussed about Rydberg's equation, this is actually Rydberg constant, right? So same thing we can also derive just applying Bohr's postulate. Fine. So we can say that Bohr's postulate, it is working well for hydrogen-like system. So now if we consider merits and demerits for this theory, merits we will see first. It can explain atomic spectrum of hydrogen atom. Then the second point, it can explain stability of atom. Now that is obviously an improvement over Rutherford's nuclear model, because that model is not able to explain why the model, if you consider from Rutherford's whatever statement we have seen in that experiment, it cannot explain the stability. But now we can explain it. And the third point is Bohr's theory helped in calculated energy of electron in hydrogen atom. And not only hydrogen atom, hydrogen-like atoms also. Hydrogen-like atoms means it may be helium plus, it may be lithium 2 plus, like this. Next, we will see the demerits of Bohr's theory. Bohr's model is applicable only to species having one electron, such as hydrogen or helium plus or lithium 2 plus, but it cannot be applicable for multi-electron system. So when it is not one electron system, suppose you have taken some 2 electron system, 3 electron system, we cannot apply this. Fine. So this is a demerit. It was unable to explain the splitting of spectral lines in the presence of magnetic field and electric field. It is observed that spectral lines, when it is in presence of magnetic field, which is also known as Zeeman effect, or it is in presence of electric field, which is also known as Stark effect. Details not required. Just remember, these two effects cannot be explained by Bohr's theory. Then it was unable to explain why electron is restricted to evolve around the nucleus only in fixed orbit. It is saying that angular momentum, that is mvr, is equal to nh by 2 pi. But why it is so? That is there is no clear-cut answer. Okay. And a logical answer for this, that is actually provided by Louis De-Broglie, which we will see in the next class probably, not today, will not get time. So that is all, again you can say improvement over Bohr's atomic model. Then it failed to explain fine structure of spectral lines. And finally, this theory failed to explain ability of atoms to form molecule by chemical bond. So why two atoms are forming chemical bond? What is the theory behind that? That also we cannot explain. And the last one, though it is not yet discussed, but it is important to mention here, that Heisenberg uncertainty principle, there is another principle we will discuss later. This also, and this is obviously an advanced principle compared to Bohr's theory, and there is a certain principle derived by Heisenberg, but it is not in accordance with Bohr's theory. It cannot explain this principle. So that is also another demerit for Bohr's theory. So these two, that is what is the statement for Louis De-Broglie and what is uncertainty principle, we will obviously discuss later, and then you will understand that it is not in accordance with Bohr's theory. The value of ground state energy of hydrogen atom minus 13.6. Because if you look at this formula for energy, ground state means what? N, that is equal to 1. And for hydrogen, we already know Z is 1. So Z is 1, N is 1. So obviously, energy for ground state of hydrogen atom, it has to be equal to minus 13.6 electron volt. Find value of energy required to move an electron from the ground state to the first excited state. That means now N will be equal to 1. Second question, determine the kinetic energy and also orbital radius in the first excited state. That is orbital radius for R1. Bohr radius given 0.53 angstrom. So for hydrogen atom, we know that energy, just look at this formula, it is directly proportional to 1 by n square or inversely proportional to n square. So by applying this formula, you can see 30, just you have to apply this formula and put in place of Z, it is again 1, but for N, now it will be, sorry, it is first excited state, sorry for that, it is actually N2. Ground state is 1. So first excited state, it will be 2. So put the value of N, which is 2 square, and this is the answer. So energy of fast excited state is this, but we have to find energy required to move the electron from n equal to 1 to n equal to 2. And in n equal to 1, we already know this is the value. Okay, so energy required, that has to be minus 3.4 minus, that is the energy for n2, minus energy for n1, which is minus 13.6, but negative negative will be cancelled. Ultimately it will be 10.2 electron volt. This is the first part. And the second part is kinetic energy. Remember, we have already derived that kinetic energy, that is actually numerically equal to, that is why there is a mod sign, numerically equal to total energy. So if you want to know kinetic energy for fast excited state, that is for n equal to 2, that is actually the numerical value of total energy. And total energy we have already calculated 10.2, minus 3.4, but we have to take mod value. So energy of fast excited state is minus 3.4, but if you take mod value, you will get the numerical value, which is the kinetic energy 3.4. An orbital radius, this is the formula, n square into r naught. R naught is nothing but it is called as Bohr radius, 0.53, 0.529 or 0.53, both are fine. And as it is hydrogen-like system, so it is 0.529, Z is 1. So that is, it is simply written. You can also write it like this. If you are not comfortable with this, you can also write 0.529 multiplied by n square divided by Z, which is 1 for hydrogen. And n value is fast nth state. It is asking orbital radius in the fast excited state. So we have to put n is 2 square, that is 4. So the value is 2.12 angstrom. Okay. So we are at the end of the session. Thank you for listening.